Let's talk about units of pressure. Maybe talking about its units, it will help us understand the very nature of pressure, which, as we said, pressure, the units of pressure, and hopefully the units help you conceptualize this magnitude, is force over area. That is, how hard or how much force do particles hit a specific area. In this case, it would be the wall of our container. In SI units, that is in metric system, the units of pressure are called pascals, and that's what this PA is. Pascal was a French scientist, and the units of pressure are named after it. This quantity of pascals is the atmospheric pressure, the one that you're breathing right now, or more or less, unless you're watching this video from the top of a mountain. And notice that Pascal by itself, it does not indicate any unit of force over area. A Pascal is a Newton over square meter. And if you haven't taken physics or you forgot about it, a Newton is unit of force, and force is equal to mass times acceleration. So mass and acceleration is meter accelerate over second square divided by meter square. So this means that a Pascal is a kilo over second square over meter. Okay, so that at least in SI units, that would be the unit of Pascal. In mechanics or in engineering, you may have seen the term PSI. PSI means pounds per square inch. You would say, well, pounds is units of mass, is not units of force. Well, but you could think that mass has, on Earth, it has a weight, and therefore it has a force. So think of, in this case, instead of mass, think of it as force, units of force over inch square. You don't have to memorize these conversions, but again, this number in PSI, or pounds per square inch, is the value of atmospheric pressure. Okay, there are other units that we will deal with in this chapter, and one of the most common units, at least in chemistry, is just plain and simple: atmospheres. So guess how many atmospheres there exist at the sea level in the atmosphere? There's just one atmosphere. That's the atmospheric pressure at the sea level. One atmosphere. Okay, we will also use something that may be a little bit less intuitive, but we will explain why, or the origin of this unit. One atmosphere, or these many pascals, is equal to 760 millimeters of mercury. And so, for example, when do we use millimeters of mercury? So when you take your blood pressure, the units of blood pressure, those are in millimeters of mercury. And so we will talk about why it is that we are using millimeters of mercury to measure pressure in just a second. And so the millimeters of mercury is actually, before I move on, you may want to stop your video here, pause it, and read this bad joke. It may help you or not. It may help you understand the units of pressure. You can pause it. I'm gonna move on. I'm not gonna read it. It's pretty bad, but it takes to understand the units of pressure to understand the joke. So we're gonna move on. So let's talk about this 760 millimeters of mercury. Why is that a unit of pressure? To understand that, we have to understand how a barometer works. A barometer, so meter means measure, baro means pressure, so it's an instrument to measure pressure. Let's think, for example, of a vacuum pump that you would have at home or in a farm to pump water. If you create vacuum in a specific tube or pipe, the atmospheric pressure can push the water all the way up to the point that the water can reach 10.3 meters. Why is that? This is based on a principle. Every time there is a pressure imbalance, the atmosphere or the gas will try to correct that imbalance. Okay, so every time that in a container you have pressure 1 and pressure 2, say that pressure 2 is smaller than pressure 1, then, and this is a wall that can move, this wall will move towards there. Okay, so this is the principle of the barometer, but also of water pumps. And it's important to remember this number. This is as high as you can get, creating perfect vacuum, as high as you can get water to surmount the altitude, 10.3 meters. So imagine that you were someone with I'm going to try someone here. Here's someone who's very happy, who has very powerful lungs and has like a straw. Okay, so he can suck the straw and has very powerful lungs and can create vacuum. This person wouldn't be able to create a column longer than 10.3 meters. All right, so if this distance is higher than 10.3 meters, you cannot pump up any water. Okay, that's related to the weight of that this column of water has. And if you do this instead of water, you do it in mercury, guess how high the column can be of mercury in under atmospheric pressure. The height of the column of mercury is 760 milliliters. That's where it comes from. When we say that 1 atmosphere is 760 millimeters of mercury, it means that under atmospheric pressure, if you create vacuum, atmospheric pressure can pump all the way up. You can pump a column of up to 760 millimeters of mercury. All right. Of course, if 760 millimeters is 0.76 meters, while water, which is less dense, it's lighter, can go all the way up to 10.3 meters. So a vacuum pump cannot pump mercury higher than 0.76 meters. This difference will tell you the difference in density. So in here I will ask you, how much dense is mercury with respect to water? Well, this distance, the 10.3 meters, referring to the column of water that atmospheric pressure can raise, divided by the 0.76 meters which is the height of the mercury column that atmospheric pressure can raise. This will give you the density of mercury. Why is that? Because the density of water, as you probably know, is 1 gram per milliliter. So, and I believe this is around 13, something like that, grams per milliliter. Okay. Hopefully these units will help you understand a little bit the nature of pressure. It's very important that you remember what happens when you have pressure imbalance, and it's also important to remember how powerful atmospheric pressure is there. Even though we don't notice, atmospheric pressure will come into place, will play a significant role when you create vacuums. Okay, or when you create the pressure imbalance, then that's when you will notice it.